So let's now move on and look at quadratic relationships and exponential relationships, and we'll compare them to linear relationships. So again, here we have a table of values. And just like when we were looking at sequences and we looked at how the values are changing, we can do that with this table of values. So here, when we go from the y value of 0 to 3, we're adding 3. Then 3 to 8, we're adding 5. Then 8 to 15, we're adding 7. Then 15 to 24, we're adding 9. So these are what we call our first differences, and they are not consistent. So we know we don't have a linear relationship, right? Because we have consistent changes in our x, we have different changes in our y, so we definitely don't have a linear relationship. However, when we look at the difference of the differences, so these are our second differences. So we're looking at the difference between 3 and 5. Here we have a difference of 2, we're adding 2. From 5 to 7, we're adding 2. From 7 to 9, we're adding 2. So our second differences, we can see, are consistent. That is a sign that we have a quadratic relationship. And what does a quadratic relationship look like? Well, here's our general equation for quadratic relationships. And ignoring the a, b, and c for a minute, I want you to look just at the x with an exponent. And notice that our first term here has an x squared. That's going to be a characteristic of quadratic relationships. They are all going to have a term that has x squared, and it's going to be the first term or the highest exponent in our relationship. So for quadratic relationships, we're looking for the second difference to be consistent. And we're also looking for an exponent on the first x term here to have an x squared. So that's going to be a quadratic relationship. Let's take a look at exponential relationships now. So for these, and again, we saw these in our unit on sequences or our videos on sequences. So here, again, we're looking at differences between the y values. So first we have a +2, +6, +18, +54. Not very consistent in the first differences. However, what we can see is that if instead of looking at adding from 1 to 3, 3 to 9, instead we look at multiplying, we can see that to get from 1 to 3, we multiply by 3. To get from 3 to 9, we multiply by 3. To get from 9 to 27, we multiply by 3. So here we have an exponential relationship where whatever we're multiplying by is the base of our expression. So in this case, it would be 3, and we're raising it to the x power to get our y value. Over here, we can see our general formula for exponential relationships. And notice that here, the exponent is represented by the x value. And so that's the key that we're looking for in exponential relationships. We're looking for a common number that we're multiplying by from one y value to another. And when we're writing the equation, our x value is going to be the exponent, exponential relationships.